Recording. Share screen. Maybe let's wait one more minute before I talk about the major announcements. Good evening. Any questions from your side? Any comments? Anything I should discuss or cover right now? Talk to me. Everybody happy? Wait, I have to find the chat. I can see the chat. You can hear me, right?
Yes.
Good. So I posted a couple of things on Moodle. I posted a sample solution for assignment 1, a sample solution for assignment 2, and I will go over both of them in a minute. I also posted instructions for the paper report which you have to create. It's a group project, and I will talk a little bit more about it. Groups are automatically assigned within Moodle, so you should be able to see your group members, and you should be able to contact them through Moodle. Topics for today: repositories, so software repositories. We will talk about mining software repositories and technical debt. So that's the main things I would like to cover today. And it's going to be also most likely our last online lecture. As of next week, we are back in person. Now, what I might try to do, office hours will be, as of next week, it will be definitely before the lecture. And I can also make myself available on Zoom if need be, okay? So if you want to discuss any topics. What else did I want to say? About the lecture. So next week it will be in person. And what I might try to do is I might also broadcast it as a Zoom at the same time. So in case, you're sick or you don't feel like coming in, 2 issues. I'm going to have a test run with my undergraduate course on Thursday to see how it goes. And so I cannot yet promise it, but I will post it on Moodle if I'm also recording / live Zoom session will be available. Okay. So I want to do a hybrid. So it will be definitely being in person as of next week, and maybe also at the same time online. Okay. Just to accommodate if somebody is busy and recorded, right? So we'll see. But like I said, I can tell you more by Thursday or Friday. I will try it out on Thursday evening with my undergraduate course and see how it goes. Quality will definitely not be the same because I will just put my laptop up for recording. Okay. Make sense?
Okay. Professor, one question, please.
Yes.
Concerning assignment 1, I was late to register for the class and I missed it. How it will be graded?
Send me an email. Okay.
Okay. Thank you.
Yep. I'm going to go over assignment 1 anyways now. And how was assignment 1? Anybody? Talk to me. it was fun, right?
Yeah.
Now, I posted a couple of sample solutions which people submitted, right? And so even these people who were actually able to fix the bug, they all went through an initial learning curve or just getting the source code, be able to build the system and also to replicate the problem. So I think these were really the three initial major problems, and a lot of people got stuck at the different steps, right? So some people had problems obtaining the source code, not really obtaining, but building. A lot of people had problems with building. And what was the challenge was what? With building. One thing, you had to know which IDE to use. Second, you had to know that you should probably do a clean build in Maven, if you use Maven. Documentation was it great? Was it good enough for a real beginner? You tell me.
No.
No. And UMLED is actually an open source project which is somewhat well documented, actually, right? A lot of other smaller open source projects actually don't have any documentation. So we had a little bit of advantage even, but it's not easy. If you're not familiar with the environment, it can become very tricky. Also, some of the documentation might be out of date. What else happened? So the next thing was actually replicating the problem. Quite a few people had actually, were actually not even able to replicate the problem. So they were able to download, to build the source code, but then they could not replicate the actual problem here. And the problem was here basically that the text is not in the right place. The label was offset. Again, the reasons are various, maybe wrong JDK, maybe operating system, maybe the wrong input, could be a lot of different things. And then the next challenge was actually debugging and trying to figure out where the problem is, right? So here we actually talk about having a mental model of the system and using some type of cognitive models, trying to understand, to improve your current understanding of the system, right? And it was interesting to see people actually use different approaches, right? But very commonly, I think it was a search. Some people used also the hints initially, which were given as part of issue tracker, right? As part of an issue tracker in the discussion, there were some suggestions where the problem could be. So, and then we actually went into debugging, tracing, trying to figure out where actually the label is placed and positioned on the screen. Now, by that time, really 80% of the people were actually reaching the time limit, or 85%. So maybe another 5% had problems actually fixing within the time frame. They were close, but then they ran out of time. And I think I had 4 or 5 people, so 10, 15%, who actually could solve the problem. So for me, it was just interesting. I hope it was also interesting for you, actually, to have to work on something which you're not familiar, which was a real problem. And if we look at the solutions are all slightly different. But it was not really a programming exercise per se, right? It was typically just an if condition and an assignment, some form. So 2-3 lines. And so the actual problem solving had nothing to do with that much with real programming skills, right? It was more really the challenge was getting the environment set up, locating the problem, trying to understand what caused it, trying to understand what caused the problem, where it's located, and then the fix, I think, was a rather straightforward, simple task if you knew where to fix it. Would you agree? And so very good here. That person actually provided the after solution, what it actually looks after the fix, right? And that's what it should have been from the beginning. So that was the objective, to have the labels correct. So here, again, slightly different approach to double check basically the coordinates. So slightly different implementation. And I think here it's again very similar. So here was another condition, basically. And always good to have basically a verification that you actually solve the problem, right? So you have to provide not just the code fix, basically your test case where you show that the problem was actually fixed. Okay. So, but I think you understand now also, most of you, why I told you 6 hours as a time limit, because you could have spent very easily, right, days if you on that project on fixing the bug. Because, you know, if you start looking the wrong direction, and you might never find it. That's happened to me during my PhD when I was writing a parser for C++. I had a problem. I got a wrong output, and I probably spent 60 to 80 hours trying to find the problem. Checked it every day, rechecked it, re-debugged, made changes, and I couldn't figure it out. After the week, I went to my supervisor and told him, you know, look, I'm stuck. I cannot figure out what I'm doing wrong. The code looks right. He looked at it, 2 minutes. And he solved the problem, for which I spent, like I said, 60, 70, 80 hours, right? Why? Because he came in with a different perspective. I always thought, you know, that's correct, right? And really what I did was I forgot the initialization was wrong. So, and that's why I typically, if I have such case studies, I will put an upper time limit just to avoid such situations, okay? And that's why I also create not, so everybody who made an attempt and who documented will get 100% for the assignment. I have already entered it in my spreadsheet, and I might upload the grades after assignment number 2, okay? Any questions for assignment 1? Any comments? Nobody. Now we will have more assignments. Yeah, case studies, assignments, basically where you're going to use some tools next and just applying some tools, getting some really real hands-on experience with some of the state-of-the-art tools, performing certain tasks. Okay, so that will be your next assignment. And you will see, so it's the same principle as assignment number 1. I will give you a problem. I will provide you with some tools which you should use and clear instructions, and you provide a log and just provide the output, maybe from the tools, but it's self-explanatory, okay? And there will be again a time limit in case you are not able to retrieve, to solve the problem. Any questions? Nobody is talking to me. Please don't do that one to me tonight. Our last online lecture, please talk to me.
Yeah, no question here.
I know, but still just say no question, anything goes, right? I'm so happy if somebody communicates with me. I need people to talk to me.
Yeah, so I
Okay.
can share my feedback, Professor.
Oh yes, please.
Yeah, I mean, for me, initially when I started the assignment, it seemed a little tougher because I'm not that much experienced in Java and building a Java project especially. So I kind of, as you said correctly, I was really going in a wrong direction initially, but I kind of figured out at a stage because of the time limit that I need to stop at some particular stage and look for other possible ways to get through it. So I mean, in that way, I mean, although I did not like completely solve the problem, at least I could reach a solution where it was kind of satisfying to me that the process kind of helped me out get the little details and understand few things which are new to me in itself. So it was a good experience altogether.
Good. See, that's what I want, right? It's like I said, all the assignments are either there for practicing, getting you ready for the midterm or final, or just getting hands-on experience, right? So that we put a little bit, that you can actually experience some of the actual challenges, right? Because not everybody has worked on larger open source projects.
Right. Absolutely.
So, and maybe not in Java, right? But I think, once you start in a new organization, you will face the same challenges, right? So it's to get an idea. Good. Next one is closer related to midterm final. It was on program slicing. You might still recall, right? So as part of a program slicing, I gave you a small program and we did static program slicing and we created a static program dependency graph. I was lazy, I admit it. I took somebody's solution just before the lecture, but I verified it because there was one or two smaller mistakes. So the interesting part in that program here was statement number 3, no, statement number 1. Let me go, wait. You can see it now, right? Hello?
Yes, we can.
Yeah.
Okay, good. I think that makes actually sense now with display. Statement number 1, what's happening?
Input is coming from main.
Yeah, we are inputting Y.
Right. And if you look at the program dependency graph, what do we see?
Yeah, here it is not.
It's
But
useless.
starting should be main and then it should be an input. Should be control dependent on that.
Nope. Yeah, but I didn't
no
provide a
use.
statement. But what we actually see, correct, who was saying it actually has no use. If you have a statement, which has
also,
yeah,
I noticed, I believe, a mistake in the solution you provided us.
okay, that could be because I just I double checked it briefly.
It's for like the slice question C, small question C. Shouldn't the 8th node be in it too?
Let's go through it. Yes,
later. Okay, yeah.
Yeah, 8 should be in it. You're correct. I can already see it. 8 should be in it. Yes.
And also, while we are on,
okay,
on that, it's another question.
Yeah.
You added an control dependency from 4 to 6.
Right.
It's an if-else statement.
Right. Because the else depends
Yeah.
on 4. On the if, right? Because the else will only be executed if the predicate in statement number 4 is true. So there has to be a control dependency. And it makes sense because to have a syntactically correct program, right, we cannot have just an else.
Yeah, true.
So I also
Yeah.
on this particular if else thing,
Yep.
I felt like 7, 8, and 13, like all the ones that have control dependencies on 6, I put them under 4 because in my mind I thought like the else is not really the condition, like the condition is on 4.
Right,
so
but it's
really dependent on 6 then.
but we still need the else also, right?
Yeah.
Here, doctor, I have one like I have
So,
research regarding the
wait.
else.
So the easiest is really because of a bracket, right? So here, anything within the bracket is dependent on 6, either directly or indirectly, right? 6 has to be control dependent on 4 because that branch is only going to be executed if the predicate is false. So it's control dependent on that one. Okay. But that's why we do the assignment, right? And that's why I talk about it. So there has to be the control dependency, and it's also needed to make sure if anything in here is included, 6 will be included, but if 6, we need the if also, right? To have a syntactically correct program. Okay.
Sorry, Professor. One
Yes.
thing. So here, can't we think of else as an else if, in the sense like we can think of it in statement 6, right? We can think of it as like else if z is greater than or equal to x, something like that. So I'm still not understanding the reason for that dependency from 4 to 6.
Okay. If you look at it, can I?
Before you add, doctor, there is one more thing I want to add regarding the else. When I was doing the assignment, I researched a lot about else and other dependency graphs as well. So as per research, it was considered that else is not as considered as a node and it's a control statement. So it's a keyword and control always goes to the next available statement in the else. So if it would be else if, then it would be a different case. But in case of else, it is never considered as a node. It's just a statement.
But it's a node here actually, because it creates a block.
Else is
right?
always a keyword. And never, when we run the program, it never comes to else control, because else is not any control statement here. It always goes to next available statement.
But it has to be right. But we have a block here, and that's why I gave it a number, right? Since I gave it a number.
That was my also question, why you gave it a number, because in many other research papers also I checked it was never a number. So it was never given a number basically.
Right, but if I give it a number, you consider the ones I give a number, okay? And it's just to illustrate, and we have to, and really to have a syntactically correct program, we actually need the else. Right? If we would not include the else, we would get a wrong program, right? So anything in here depends on the else, and the else itself depends on the outcome of that if statement. So there is a clear dependency between the if and else. Else is only going to be executed if is false, correct?
Yeah.
And if else is executed, anything under else, within the else block, is going to be executed.
Yeah.
So there has to be a control dependency. And that's why I give it a number, just to make it very clear. Okay.
Okay.
So other interesting
From
parts.
next time onward in exams as well, if you give a number to particular
any statement which has a number you consider.
Okay.
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 Good.
Okay.
So I make it very I have a very straightforward rule, right? Anything which has a line number you consider.
Sure.
So the main has no line number, we don't consider the main. Okay. The reason is really to simplify also the diagram, right?
Yeah.
Otherwise, anything in here could have a dependency on the main, and it just becomes messy. So that one here is interesting.
Sir, can I interrupt?
Yes, thank you.
Yeah. So because 7, 8, and 9, 10 are dependent on the 6 statement for control, shouldn't they be dependent on the 6th statement? Sorry, 4th statement for control as well? Because I don't see any control dependency from 4 to.
Because you're correct. If you draw it, it wouldn't matter, right? Because it's based on transitive dependencies. Because if you have a control dependency between 7 and 6, and between 6 and 4, you also have indirectly. Wait. Give me a second. I'm getting there. PDF is a little bit more tricky, right? So we have statement number 4. Oops, 4. We have statement number 6, right? Control dependency. And we have, for example, statement number 8, right? Or 7. That's good enough. Control dependency. So yes, you're right. You could draw another control dependency between 4 and 7. But since we are traversing backwards anyways, we basically have a transitive dependency, because if 7 depends on 6 and 6 depends on 4, 7 also depends on 4. It's just to simplify the graph, okay? If you draw it, it's not wrong, but it's not needed in terms of slice calculation, okay? Does it make sense?
Yeah, that makes sense.
It's really just to simplify the drawing. Otherwise, you get such a messy drawing, right? And
Yes,
so
sure.
Statement number 9, if I continue here, right? Would be good enough. 9 is control dependent on 7, not on 8, sorry. Okay. 9 would be control dependent on 8. 8 is control dependent on 6, and so on. Okay. So there's no need to draw a dependency between 9 and 4. If you draw it, it's not wrong, but it just makes it messy. Now, I will answer the question in the chat in a minute. I just want to talk about my highlighted up here, right? About my statement number 1. So it has no data dependency. It has no control dependency. What does it mean? A variable was basically declared, but never used, right?
Yeah.
Yeah.
Does it sound familiar what a compiler would report? A variable was declared but never used, right? So that type of data dependency checking is actually what also a compiler does, right? So if you declare a variable and it's never used, or it's reassigned a value shortly after, and it has basically no impact, right? So the variable is never used anywhere. Compiler will spit out a warning, right? And that's how the compiler would actually identify, because there is no dependencies. Okay. So we would see here's something wrong. Good. Now, what else was interesting? One has to consider the loop. So when are the variables assigned? And the interesting part was mainly X, which was a little bit of interest here. Sometimes the value of X was coming from before, from statement number 11, but it could have also come from statement.
Hi, Professor.
Yes.
I have a question. Why is there not a self loop on 11 on the graph?
Yeah, there should be a self dependency on 11.
Okay, let's wait. Let's look.
Sorry to interrupt you.
Yeah, no, let's look. Statement number 11, right? X is used. Where's the value of X coming from? The first time it comes from statement number 3, right? We agree. So for the X, right?
If we have to go backwards,
and then
it is also dependent on Z. So first of all, Z will come on from 9th.
Right. So Z, but if you have a self loop, Z really doesn't matter. It would actually just be X, right?
But
so,
it is getting at it is changing the value of X, so it is self-dependent.
Oh, let's see. So X is getting the value. The first time, the value of X is coming from statement number 3, right? When we go out of the if statement, and there's another assignment, X equals X minus 1. So the latest, that's the new value of X is coming from statement number 12. So the next iteration, the value of X is not from itself, it's from here. So there should be no self loop. Because the value of X is not coming from itself. It's coming either from statement number 3 or from statement number 12.
Yeah, but it is still
nope.
Due to X, the value of X is getting changed, no?
Yeah. No, but which value is used? Remember, the data dependency means...
Yeah, data dependency is on 9th and
also
on 11th is dependent on 3, yeah. Data dependent on 3.
But it's not data dependent on itself. It's not data dependent. The value of X, of that X is not coming from here. It's different here. In statement number 12. Where's the value of X coming from? Yes, it could come from 11. But if you don't go in here, it actually comes from itself. Aha. So that's why they're different.
It does not come here. If condition is true, then it is getting its own value.
Right.
Like we do not sum is equal to sum plus this particular integer. But in that also, when we are assigning the value to the same variable, it is dependent on such.
But where is the value coming from X? Here.
From third statement, obviously.
From the third or from 12. In the first iteration, it comes from that the value of X comes from statement number 3.
Yeah.
In the second and later iteration, it comes from statement number 12. The value of X.
But if that once if is done, then obviously it will, once if is done, it will go to this because it's in a while. So
right.
It will get another, yeah.
So it will never get the value from itself.
Sir, can I interrupt, please?
Yes.
Yeah, so actually, Aditi, what sir is trying to tell you right now is that the 12th is
in case if it is coming from 12, then it is not that. But if it is not coming from 12, then it would be set.
But it has to, right? Right now it has to come from 12.
Because it will go in a while loop, yeah.
We are within the while loop, right? So it always has to come from 12. Yes.
Yeah.
Sorry, I interrupted. Whoever started talking, please continue. Hello. Who started? Raise your hand. Yep. Go ahead. Talk. Stanislas.
It was not me, but I just want to point out that there is an arrow missing from 3 to 11 on the graph.
Let's see, 3 to 11.
No, it's 3 to 11.
The value of x is coming from.
I think
Nope,
it is there.
It's
from the
where?
right hand side. Is the
3 to. Oh yeah, right.
So
And,
I double check. Yep, good.
But 3 to 12, if it doesn't go in the if loop, in the if statement.
If it doesn't go in the if, right? Where does the value come from? From itself. The first time it comes from 3.
Yeah, and so there isn't this arrow from 3 to 12.
And so the first.
There should be a data arrow from 3 to 12 in case
you are
the first time it
correct.
doesn't go in the.
Yeah,
in the
I agree with Stan.
You are correct. You are correct. I will fix it. Thank you.
No worries.
Because I was talking about it, right? And I just.
That's what I saw it.
Yep. Okay. So there's one data dependency missing. Because, like I said, I reused somebody's solution. Okay. So, and basically the slice computation is basically going backwards, traversing backwards all incoming edges. So we take any node like set in statement number 15, and when we traverse backwards all incoming edges, we can reach 9, we can reach 2. From 9, we can traverse backwards to 8. Agreed? From 8, we can traverse backwards to 12. From 12, we can traverse backwards itself to 11, to 10, to 8, to 2. And that's how we calculate the slice. Okay?
Professor, sorry to interrupt you.
Yes.
For Z15, is 3 missing? I think 3 is missing.
Oh, yes, sir. Because the person, I had to update the whole slice. It will be updated. I just did it just before the lecture, right? As said, 15, statement number 3 is missing. You are absolutely correct. Because we can traverse backwards from 10 or from 11, we can traverse backwards to 3.
Z15 is not dependent on 3. Like
15.
3 is getting a value of x, no?
15 is data dependency on 2, on 9.
Yeah. But
on
15,
8.
Z value is not coming from a third x value, no? Third point x value.
From statement number 3?
Yeah, statement number 3 is just taking an input value of x.
Yeah, but it's still needed for.
It's control dependent, not data dependent.
No. Statement number 4 has what?
4 it is depend. Obviously, x is used.
So if you look
have
at
a control dependency.
But no, yeah, but look, that graph is correct, except that there's one data dependency missing, right? And all what you do is you traverse backwards all incoming dependencies. It doesn't matter if it's a data or a control dependency.
Yeah, we have to write both, yeah.
Okay, so you go from 8 to 6, from 8 to 3.
Yeah.
Everything is included. So there should be statement number 3 has to be included here. And for and if you go node number 14, we get obviously a different slice, right?
Yeah.
Okay.
We have 2 slice points, right? 14 and 15, and then we have to traverse, right?
You always traverse backwards.
Yeah.
Now, for the static forward slice, there's again.
Sorry, Professor.
Yes.
One thing. In the first one, SZ15, I think from 9 to 15, we are directly getting the values, right? So 10, 11, 12. Can you just explain once again why we are including 10, 11, and 12 there?
Yeah. So you traverse backwards all incoming edges, right? From 15, we can reach 9. From 9, we can reach 8. From 8, we can reach 12. From 12, we can reach 11. From 11, we traverse backwards to 10, to 8, to 2, to 3. From 6,
Okay.
we can traverse backwards to 4. From 4, we can traverse backwards to 2 to 3. It becomes really a mechanical task.
Okay, so actually how I did it is I didn't do it through the graph. I did it through the code itself.
Yeah.
So what I thought was like from 15, the value directly will be coming from 9 to 15.
Yeah,
So
which
and
is
also
true.
from 2.
Which
Otherwise,
is
if
true.
we go without graph, we will go by 9 and 2. And when it comes to graph, we have to show control dependencies and all that. But when it comes to just giving a point.
Remember the objective of program slicing is to create a behavioral equivalent program for our point of interest, at a point of interest for a variable of interest. So if we compute a slice, and if we execute the slice, the value of the slice for our variable, in our case, in that example for variable z, should produce the same output as the original program. So we basically want to guarantee that the value of z is equivalent in the slice and is basically the same in the original program and in the slice. But we only guarantee it for our slicing criterion. And that's why we need all the loops, all the conditions, right? Because we have to make sure that the final value of z is going to be the same.
Yeah, so but if you see from 10 to 12, the value of z will not change at all. Whatever will come in 9 will be printed on 15.
Yes. Whatever will be on 9 will be printed.
But you might input it here, right? In the loop.
Yeah.
That's how it works, right? It depends on the loop iteration. It's just a mechanical. You just do a mechanical task, right? That's why we create the program dependency graph, okay?
Okay, so
doctor, if like in Z14, we only have
you traverse backwards all incoming edges.
Okay, so
mechanically.
Just to make it clear, Professor, what I want to say is like it's better to traverse through graph, because if we just see the dependencies,
you might miss
of the
something.
value. Yeah, because from 9 to 15, whatever value is inputted in 9, it will come to Z, or either it will come from statement 2.
Yeah. But you need also the while loop, because otherwise you might never get there, right? It also, you create a subset, right? It's not, because now remember, I give you only one input for Z, right?
Okay.
If I give only one input for Z, it could be, for example, 2, but here I might enter 5, right? With your approach, if you don't have the loop, you would give me as an output 2, but it might be actually 5, but it should be 5, right? So we need the loop. So just take the program dependency graph and traverse backwards all incoming edges, and you are safe. Okay?
Okay, that's the better
it's the correct way, right? Because that would be the example. You would have told me, I need only 15 and
9.
15 and 9, right?
No, for Z15, 9 and 2, and for 14th, if we do go by data, it's 13th and 3rd statement, because in 13th it's always gonna be.
I was just referring to him, right? He only wants to take 15 and 9, right? Which would make partially sense if we have only one set, right?
Yeah.
So, but it's a very good question. So just take the program dependency graph and traverse backwards all incoming edges.
Sure.
Mechanically, don't think.
Yeah. On the second one, X14, actually what I did is I included 9, 10, 11, 12 as well, according to the data itself, because there was some manipulation happening.
No, not in the graph, right? You follow the graph, right? And you cannot reach it. So it's not needed.
Got it.
Now,
got it.
I have a problem in here in the forward slice, as pointed out, number 8 is missing, because the change is at 9, 10. So now we do the outgoing edges, and I can also reach 8. Okay, it's from 9 to 8, from 8 to 12, from 12 to 11, from 9 to 10.
But
Yes.
Professor, isn't forward slicing just
After
we go forward, right? We don't go backwards. We
Yes.
cannot go
You
before
do.
9.
You basically follow all outgoing edges. Okay.
Okay.
Because it's in the loop. So 8 might be, right? 8 might be affected, but your loop iteration might actually be affected. So 8 has to be included. You just do it mechanically again. I just omitted it. I forgot, right? So from 9 to 8, from 9 to 10, from 9 to 11, from 11 to 12, from 12 to 10. Okay, and from 9 to 15.
So why is 9 itself included?
Yeah, why is 9 included?
That's where we make the change. So we should include it. Okay.
Like it's an input and
so here we also include the slicing criterion should always be included.
Okay.
Okay.
Yeah, that thing I got, but yeah, I was just asking about the 8 part by 8. Yeah,
Yep.
got it.
Okay. So you
like
just do
8 is in a
again
while condition. That is why we have to take it, because otherwise it's in the forward slicing. We don't have to consider
correct.
where it is.
But you wouldn't have anyways if it's not in a while loop.
Yeah, it would not have been happened.
You would not have the data dependency anyways, right? So you have a different graph. So just take the graph and then do either for backwards slicing, you traverse backwards all incoming edges. For static forward slicing, you traverse all outgoing edges. Okay.
Yeah. So what is confusing is if we follow all the outgoing edges, do we get back to 9? I don't think it's possible.
Yes.
Okay. Yeah, with the control. Yeah.
And 9 should be included just in case, right? Because that's
So,
where we make the change. Yep.
So sorry, Professor. So hypothetically, if we have a while loop outside this, then it might go to like let's say 6 or 5 as well. Right?
Yep. You just follow the graph, right? Whatever you can reach with forward. That's it. It might affect it, right? Which also makes sense, right? If you change something within the while loop, it might affect the beginning of a while loop, right? Any statement within the while loop might be affected. So it's really neat, right? And so we create one graph and you get 2
answers.
Yeah.
And one more question, Doctor, here, like when we make a graph, obviously we follow the control dependency, data dependency, and we follow each and every statement and their backward slicing. And automatically the forward slice would happen because once we
if you want to,
every
right?
line.
Yeah, if you want, you can compute for any variable, for any node,
yeah,
right?
It all automatically happens when we do for each line statement.
So that's like in the midterm, I will ask you to create a program dependency graph maybe, and then I will tell you compute a backward slice and the forward slice. Similar like my assignment, right? And so now you know you create once the graph, and then you can easily compute the backward slices. You can easily compute the forward slice. Now, what happens if you if you make a mistake in the exam? Everybody makes mistakes. You know, if there's only one dependency missing, and that results in a problem, I often overlook it, right? Because like you notice, if I do it quickly, I make a mistake, right? But if there's more things wrong, I will subtract, obviously, points. Okay.
Will you do that for the assignment too, or?
Assignments, you get 100%. If you put an effort in it, that's my whole idea, right? Any assignment is not to punish, it's for practicing.
Okay, yeah. Thank you, sir.
Right? Because I try a different approach, right? I don't want copy paste. I don't want to look for cheating or whatever. You have an opportunity, right? If I see obviously 2 assignments which are identical, I will give 0, right? I want people just to put some effort in. If your slice is correct, it's perfect. You're on the right path. If something is wrong, look at the solution and try it again, okay, for yourself. Assignments are just to provide you with feedback. And as long as you put the effort in, you get 100%. Like for the first assignment, right? If you solve it or not solve it, I just want you to experience it. For me, it's not all about, I get my grades out of midterm and final and the paper report. Does it make sense?
Yeah.
Yes, yes.
And here also to add on, doctor, I would say it's a benefit that you discussed this assignment because there were confusions with people.
But
I believe everyone that whether every statement was to be considered or not. And now it's clear because from next time we will take care of this while doing the.
And I will update the solution after the lecture with the correct values. Okay.
Yeah.
Perfect.
Professor,
yes.
Just a quick question. Like in statement 1, 2, and 3, like we are taking inputs, right?
Yeah. So
like we are taking the inputs from the user for the first 3 statements, right? So like so like why there isn't a self loop, because like that particular value is coming from itself, right?
No. Who's assigning the value? It's not another variable. It's not the statement number 1. That's where we just define it. But there's a self can only be in a loop if we execute the statement multiple times. Every statement, you only, here you only execute once. There is not a self-dependency, right? Even if there's anything there, right? There cannot be a self-dependency.
Okay, like so it's not
it's
the case
only if we potentially execute the statement multiple times. And even when, you have to look, it's only for 12.
Yeah.
Right?
Okay, so, okay. Yeah, thank you.
Good. Let me close.
Professor, I have a question. It's a generic kind of a question. So here we were asked to, identify the slices for those particular nodes. So my question is, does that node itself, is that node itself included in this slice, or should
yes, included. So 15 should always be included, 14, and 9 has also been included.
Okay.
And then I had another slicing problem. Same idea, just not a program dependency graph, but it does have data and control dependencies. Okay. Have a look at it, and I can always talk about it next week. For me, obviously, that one is easier to grade because everybody would create something different, right?
Yeah.
For this table, shouldn't there be a control dependency from 8 to 6?
From 8 to 6, I thought
like in control, because like if it's an if else like before.
I missed it. Sorry.
Because
I thought it was to 6. But why do I have 8 to 5?
It's in a while.
Control dependent on.
It's in a while loop, and it's the else of the if.
Yeah. No. Yeah. I skipped it because I used the same solution and I didn't double check. That person didn't have the error, right?
It's the same error as before. It's the else if that's not dependent on each other.
I will check it. So we have between 8 and 6 there's the problem. Okay. It will be updated. Very good. Thank you.
Yeah, I did the same mistake as he did with the else if. So I
in the previous and we discussed else
because I took good. Now. Now I have to move on. Paper report. Oh, that should be probably 7 pages now. I can't remember how many people I assigned to each group. 5, 4, 5.
I was just going to ask, I can't find the groupings on the module.
You should be able to see it, right?
Yeah.
Is it a documents?
It should be under participants or whatever. You should be able to see.
It was in the message section.
And on the message section, you should be able to see it. somewhere. Just look around and you should be able to contact your group members. So we have 4 to 5 people. And basically, I provided a very detailed guidelines, which you should follow, including some formatting guidelines and also resources in terms of papers, okay? Where to find papers.
Here I have one question, Doctor. If we get data from other scholarly articles as well, we can add them to reference and add them, or we have to go for these 3 only?
No, you can go for other resources. You can go directly to IEEE, right? Or to ACM or to any of the journals. But these are just...
And we can mention that where we have taken the reference.
I want the proper reference, like you see it in a paper, right?
Yeah.
These are just good sources to find some potential papers, right? As a good resources, right? To identify papers.
Okay.
And I think the guidelines are pretty straightforward. Please make sure to address the different parts. I don't want just copying it. Just put your own thoughts in it, right? If you're right or wrong, again, I would just want you to think, trying a little bit, think outside the box, right? Try to interpret what you read. You can criticize the paper. Fine, perfect. Okay. So if it's correct, fine, but then highlight why you think it's good, right? Okay.
So I have one question, Dr. Eiling. When the paper has been distributed between 4 to 5 people and they aggregate it, and at the end of the day, the whole integration is submitted, then how it is being evaluated?
I will look some parts. Basically, I create a spreadsheet. I will look at different criteria. It's an introduction, right? But obviously, I will look also, a big chunk will be on the each individual part, okay?
Sure.
Now, you will get some points, right, for the common parts, but the individual part will make up at least 60, 70%. Okay?
That's great. Yeah, thank you.
Just to avoid, if there's a problem with the integration, right? So you're not getting punished. Also, if somebody does really most of the work and somebody doesn't do anything on the other parts, I might lift the one person who does everything and reduce the one person, but that's why I'm asking also for the contribution, right? You have to provide some information about the contribution.
Yeah.
Okay, good. Now let's teach something finally. Last lecture, where did we finish? Today it's going to be interesting. Once I find my right lecture notes, it might be interesting. Last lecture, we were talking about issue trackers. So software repositories, issue tracker. We were talking about the life of a bug, issue trackers. Then we went into versioning systems. We looked at different scenarios when people were working either solo, which is easy, but basically just making backups. If people are moving around, you might create copies and take them with you, or you might have a central server. And then really the solution would be just to have a version control system where you have a central copy and where you can check out. Interesting part about the versioning system is if we create a backup or a new version, they don't store the whole thing. They only store the changes, and then they can basically recreate the whole document based on the deltas, on the changes from each commit. We talked about different working in a team where we have to deal with concurrency. The first one was basically pessimistic concurrency, where we would prevent complete concurrent working on a file. So only one person has write access. Multiple people could have read access. And the lock is only undone whenever the person who had the lock has committed their changes. And then people would have to get the latest version from the central server. And then there's an optimistic concurrency, which is really multiple people have read-write access, which is basically the state of the art. And then the major challenge here was you have to merge at one point. So you have to merge the changes. And then we looked at basically the scenario where if two people are checking out, one person here, Angela, commits the changes. And now if Hassan wants to commit his or her changes, it would fail because he would basically get a notification the repository has been updated. And what Hassan would have to do is has to get basically the latest version from the repository, compares it with his updated version, with his own version, and then basically commit a merged version, which has his changes and the changes in the repository back to the repository. And that's basically what we looked at. I also mentioned that automatic merging, even if it looks possible, like in the top, it should be avoided because we have no idea if we do fully automatic merging, what is actually the final result. We might break the semantic, we might cause other problems in the program. And so there should be always a human has to verify that it's actually still a correct program and that it meets our requirements. And it becomes obvious if two people change actually the same line of code, who is right and who should and how should it be changed. So that's a real conflict. And that's what it might look like. Okay. Version controls system are not only used for source code, they can be used for any type of documents. And also the benefit is, you have really undo. Basically, you can roll back to a previous version. And it allows you also to see who changed what and when, right? So it provides us insights, a log basically of changes. Now the next one is really the state of the art these days. It's basically distributed versioning systems. And it addresses actually some of the shortcomings of a traditional versioning systems like SVN. So where you have basically every user commits each time directly to the server. So you make a change, you're ready to commit, you commit your changes directly. So that was the traditional approach. You always committed your changes directly to the server, and you had always to merge whenever you made a commit. So the problem was you ended up basically with a traditional versioning systems. You ended up with a lot of commits, a lot of network traffic, and a lot of small merges. So each time when you committed something, you had maybe to, depending if somebody else had modified it, you always had to merge it. So another approach was actually distributed versioning. It goes back really to Linux. So back to the early 2000s, 2005. And basically everybody, the way it works is, in a nutshell, everybody checks out a copy of a repository, of a central repository. And in the next stage, any commit, and that's your local repository is basically treated like a sandbox. So you work on your within your sandbox. So whenever you commit something, you commit it to your sandbox initially. So you're not sending it to the central server, to the central repository. You just do it within your local repository. what it does is the merging, there's no merging initially because you are the only one working on that repository. You reduce the network traffic because there are not many commits. Also, the advantages you have, since everybody is basically downloading a copy of a repository to the local machine, you do have backups of the server. Whereas on the centralized version, you had just the centralized repository. And if that repository, for example, went down, nobody could commit anything. Also, you had to take care of a backup of the central repository manually, through some backup settings or RAID environment or whatsoever. Okay. So these are the basic. So you get version control even when it was detached from the server, right? So that's just an initial, simplified basic workflow. So first you clone the initial repository, then you can edit some files, then you stage the changes in your local repository, you review the changes, and once you're happy, you commit them to the server, and then you have to do basically the merging. So that's why it said in here, reduced merging initially, because at one point you will have to merge. And then the merge will involve basically all the files which you have changed. Yeah, I skipped that one. So we have a head, we have a working directory. So you check out the project in your working directory, and then you stage the files in your sandbox. Basically, you verify that it's correct, and then you commit it at one point to the head, back to your central repository. Okay, but the important part is you work initially just on your working directory. Good. It's a very simplified version, and here it goes a little bit more in detail, but I'm not doing a complete Git tutorial here. Okay, so you edit your files. Here's a flow, stage the changes. You review your changes which you made, and here's just some of the commands which you can use. And so, and then at one point you commit your changes to the server. Okay, so it goes basically back to the head. Now, the problem with Git and with distributed repositories goes back really, there's a lot of flexibility in terms of, you can work on your local repository, you make changes, and you only commit once you're really done. But the question is, when are you done? When should you actually commit your changes back to a repository? Is it on every night? Is it once you're done with a feature? Is it once in a month? And that's where basically some of the workflows becomes difficult. So an organization has to have clear directions on the process which should be followed, how frequently actually people should commit changes to the central repository, to the Git, to the head branch. Okay, so that's the interesting part. That's the challenging, because with a traditional versioning system where we had the central repository, each commitment basically always to the main branch, to the main repository. Here, we have to determine, we collect changes in our working directory, and the question is how many changes do we collect before we actually start the process of committing. And there are different approaches, different types of workflows, and they are really organization project dependent. Good. Oops. Any questions? That was a really brief. So distributed versioning is the current state of the art. It has probably more benefits than shortcomings because a lot of these workflows have been worked out over the years, right? And there are enough templates and examples out there which can guide organizations. Okay. Good.
Dr. Eiling?
Yes.
Here I have one thing to add on. Like obviously we have Git commands and everything, but these days every IDs provide smart Git and merging with them. So we should prefer these, right? Instead of going and typing.
Yeah. So these are just the basic Git, right?
Yeah.
Now, obviously, it's all now integrated within your IDE, right?
Yes.
But that's why I didn't talk much about it, right? It's I don't want to give a complete Git tutorial. So, but what I showed was just a couple of command lines, right? And most of you don't use them anymore. You go for your IDE. So that's why I skip it.
Yeah.
But having all these syntax, so really distributed Git has a lot of more flexibility in terms of controlling your commits and working on your local repository. So it's much more powerful than your traditional centralized versioning system.
Yes, exactly. Yeah.
Good. Now let's go in something really cool. Back to software traceability. Should we have a short break and then continue? Because I just noticed it's 4 to 7. Should we continue 5 after 7?
Yeah.
Sounds like a plan.
Sounds good.
Good. Let me just stop the video, pause it. Test. I know it might be a little bit short of a break, but can you hear me? Can you see me?
Yeah, doctor.
Yes.
Okay. So before the break, we talked about software repositories. And now the focus is basically on what else can we do with these software repositories. And I'm going to provide you a context. Remember last lecture, I think we talked about software traceability, right? Correct? Where we talked about traceability linking between different artifacts. And traditionally, software traceability was based on very rigid processes of the artifacts. And mostly we were linking basically artifacts when they were created. And it was part of a quality assurance program, right? But like we discussed last lecture, they worked really well for document-driven approaches. But obviously, once we have agile or non-document-driven approaches, we will run into problems. So now a question came up, basically, how can we deal with traceability in such agile development context, where really documentation is of lesser importance or not available at all? And with documentation, I'm talking about really formal documentation. Okay, so that's our context. And basically, the next 25 minutes, I will talk about mining software repositories, and these lecture notes were actually adapted from Queen's University and from North Carolina. That was given at a ICSI conference a couple of years ago. So the idea of mining software engineering data and therefore repositories is transform static record keeping data and make it active, actionable data. And with action or actionable data, meaning predict something, identify patterns. Is there something what we can identify from the data? Reoccurring patterns, maybe trends. So uncover hidden patterns and trends, which otherwise would not be obvious to the end user. So such empirical software engineering data can be used, gain empirical based understanding of software development. So the idea is, we collect data from real projects, and then we can analyze these real projects to get a better understanding on how well we do, what are the problems, etc. It can help us in predicting planning and support future development. Okay, good. So what's the basic idea? As input, we do have any type really of software engineering data repositories. So could be source code, right? But could be also issue tracker bugs, versioning systems, but could be also other artifacts like Stack Overflow, could be log files, could be you name it, right? Any type of data. And then what we do apply is basically some machine learning, data mining techniques like machine learning, deep learning, classification, association, pattern clustering. And we have plenty of more neural networks. Now, each of these techniques has the pros and cons and work better for certain type of data and certain types of pattern what we want to identify. And then the idea is based on the analysis and patterns, which we identify, let's say, put it under machine learning. We can support programming, defect detection, testing, debugging, or software maintenance. Okay. So that's the whole objective of mining software repositories. I will not talk too much about the individual actual technique and tools because we are constantly changing. The mining software repository area was in the last 10, 15 years, probably the most active area of software engineering, software evolution. It has replaced a lot of the traditional techniques like program slicing and other techniques were partially replaced for mining software repositories. And we will see how and why. Okay. So historical data, like I said, could be any thing from versioning, issue tracker, execution traces, source code repositories, but could be also like Stack Overflow, other things. Okay. If I'm going too fast, let me know, but so history in general is where to guide to is a guide to navigation in perilous times. History is who we are and why we are the way we are. So it helps us explaining, it helps us understanding, and it can also help us navigating by learning from the past, navigating the future. So historical data is where for tracking the evolution of a software, and one of the main resources would be what? A versioning control system. Issue trackers could be used, or some mailing list archived project communication, right? Where people have discussed what should be done, etc. Now, if we look at this data, initially, we just look at what? Just an archive, just some form of record keeping, right? Initially, by just looking at it, we might not really be able to interpret or infer anything other, right? Because, you have to look for these artifacts. Somebody chat? Okay, I will come back to that one at the end about assignment 2. Okay. Because so basically what we can do is by mining some of this historical data, we could identify, for example, how much effort, how much cost are we devoted really to maintenance, right? And that is what people have done, some studies. They use some of the archive data and just look, how much time people spend in the total for maintenance. And that's a very straightforward type of mining of this historical data. I bet, you could do the other statistics looking at what type of issues and, are they perfective, corrective, adaptive maintenance. And basically you can do a classification and an analysis of your historical data, which would be still considered mining software repositories. But here we are just doing a simple classification. Nothing really exciting, right? It's more like reporting. Now with machine learning and deep learning and neural networks, we can go actually broader. We can try to find something which is not as obvious, and which is what people have tried. So we know that a version as a system tracks the changed units. So that could be at the file level, at the function level, even dependencies could be part of it. And for each change, for each commit, basically, we know also the developer, we have a change message, and often we can also identify what else has been changed together. Because you might commit not only one file, you might commit 2 or 3 files at the same time. And then the assumption is they might be actually all closely related to the same problem. Okay. So now, traditionally, let's say you have a new requirement, a bug fix. How does it change if one source code entity propagates to other entities? In a traditional approach, we have a new requirement, a bug fix request. We determine the initial entity to be changed. Like in our assignment number 1, right? You figure out where the problem is, you change the entity, and then you should actually look if that change might affect other entities in your program, other parts. How do you know? You ask a guru for advice, meaning somebody, either an expert, or you have a tool like program slicing, static program slicing. Okay. So, and then you basically suggest new entities which might be affected by the change until the guru says there are no more other ones affected. Now, slicing is not traditional gurus, right? Traditional techniques like slicing, they are not always scaling well. So here we could use forward slicing, right? So that would be an example of an application of forward slicing. You have a change entity and you would like to know what else is affected. Now, slicing, however, does have problems in terms of scaling, in terms of parsing. And we talked about it because you need specific parser for specific languages. They don't deal well with multi-language systems. The slicing doesn't really work well for distributed systems. So there are lots of limitations. So we need something else. We might not always have a guru around and an expert. Before we look at what actually mining software repositories can do, there's a general approach for all these mining techniques, how they're typically evaluated, and it comes actually from information retrieval, it's recall and precision. So for a lot of these mining techniques, what we use to evaluate the quality is recall and precision. The recall is how many of the true positives can we actually obtain without any reporting any false negatives. So we have 50 true positives, but we only report, for example, 40. The second one is precision. How many of the ones we actually report are actually true positives, are correct answers? And how many are false answers? So ideally, we would like to have a recall of 1 and a precision of 1. Reality is, for most of these tools, typically, if we try to improve our recall, meaning we are trying to find all correct, all true positives, the ones who should be reported, we might have to ease or be less restrictive in our rules, meaning we allow for also false negatives being reported. So we might report things which are not actually, should not actually be reported. So, and for precision, sorry, that was for precision what I said. For precision, we might have to restrict our rules in order to have less false positives, meaning false answers included. But having more restrictive queries or analysis will limit our recall, because we might actually miss also some of the true positives of the real things which should be reported. So there's typically a trade-off. Normally we cannot achieve both at 100%. That would be the ideal situation, but typically we try to improve recall, and often the precision goes down, or we might try to improve precision, but then our recall goes down. Okay, so people have mined the software repositories to identify change propagation. How did we do it? They basically looked for the version control system, and they looked at the file. Remember our starting point format change, and looked for the versioning system. Whenever that file was changed, what other files were changed at the same time in the past? So basically we use historical data to help us predicting based on historical patterns to identify what might change this time again. Obviously, the situation is each time different, right? Well, once we might have added a feature, once we might have fixed a bug, and it might not have been the same bug, but we just look at patterns in the history, in the historical data, and then basically try to reuse that type of information from these old patterns and apply them in our new context. And what they found was that the recall was as high as 44% of the time. They could actually identify the correct files, artifacts which had to be changed, and the precision was around 30%. So 1 out of 3 was correct, and 2 were false positives, meaning just they were not actually correct files, files which didn't have to be changed. So the prediction was not very precise. Now, these are old studies. Nowadays, with better machine learning techniques, and more data and more learning data, these techniques go up to 70%, 75% at least in recall, and precision is also similar range. Because that study is really going down back to 05, early days of mining software repositories. So by having better machine learning, more powerful machine learning algorithms, and more learning data, better learning techniques, we basically could double, at least around double our precision and recall nowadays. So traditional dependency graphs and program understanding models usually do not use historical information, right? Because we create the program dependency graph on our current version. So it's a static view of the system. However, if we create graphs, program dependency graphs, or any type of dependency graphs for all the different snapshots of a system, we can get actually a much deeper understanding of how the system evolved, okay? And we might be actually, again, able to identify certain patterns. Now here, what we did was, we looked at who committed, who worked on which file. And what we actually identified, based on the commit, you could actually identify the teams, the team members who worked on which subsystem or in which team, who actually collaborated, who might be an expert in certain areas. So basically you can recover just from a versioning system some organizational structures. Why is it important? You might have a conceptual architecture of your system. You might have an ownership architecture. Who is supposed to work on what, right? So you have a certain number of people, whatever. But and you have also specified the communication process, who should communicate with whom. But when you look at the real thing, you see that there's a different type of dynamics in your structure, that people actually might communicate or call different parts, and you actually see much more insights, right, between the real dependencies and what you actually designed. Okay. Now, predicting bugs, another very popular area in mining software repositories. Where are we going to have bugs? How many bugs do we have? Which part of the software is really the most buggy ones? And basically what people have found is that previous bugs are a good predictor for future bugs. And what we also observed was the more file changes, the more likely it will have bugs in it. Also, we observed that recent changes have a larger effect on the quality than older changes. And number of developers is of little help in predicting bugs. So it's not necessary. So at that time, it wasn't really, they couldn't find a high probability that the turnover or the number of people working on a product, on a class, on a pocket, on a package, for example, might be a real reliable indicator that it might be of low quality, have a lot of bugs. But still, people could figure out certain things. And now here it becomes actually much more interesting, much more concrete. So people could, for example, now, by looking at the historical data, they can predict bugs. For example, 71% of the files that import a compiler package had to be fixed later on. So anybody who had an import of a compiler was a 71% chance that it had to be fixed. whereas files that import the user interface package had only to be fixed. So the UI user interface parts, programs which use or just user interfaces were less likely to have bugs in it. What could be the reason? Compilers are more complex. Probably there's more likely that you make mistakes. GUIs tend to be more simplistic in their syntax and in the semantic in terms of the programming. So less likely to have probably an error in it. Okay, but still, so we can predict, right? So anything which uses a compiler, better make sure it's well tested. You have enough test cases. It's well documented. So if you have that type of information, you can actually you can do preventative maintenance. Design it, but it's easy to fix, easy to comprehend. Don't program on Fridays. Percentage of bugs introducing changes for Eclipse. So they looked at Eclipse. They looked at the commits, and they looked how many of these commits committed on a particular day had actually later on bugs. How many of the bugs which were reported were introduced by commits on a Monday, Tuesday, etc. And what one can see is that Friday has the highest number of bugs introduced. And Tuesday looks like the best day. Why? Anybody has an idea? Why would we have probably the most bugs on a Friday?
It's because TGIF. Thank God it's Friday and people are like in a relaxing mood.
Correct. And Tuesday, Monday might be still, you're not still 100% there, but Tuesday you're still pretty rested, right? But how would you use it as an organization? That type of information. How could you use it?
Don't push to production on Fridays.
Correct. Don't try to push out your final release on a Friday, right? Best day would be probably Wednesday, or say, oh, we release our product on a Wednesday, so the final rush is on Tuesday, right? So that's how you should use that information, right? Could be used to improve your development processes.
Professor, isn't this a little bit too coincidental, to say the least? Because I mean, if there are 100 bugs, the difference will only be of 1 or 2 at best from the best day Tuesday and the worst day Friday.
Oh no, they actually looked at thousands of bugs, right? A lot of the systems have a large number of data points. So mining software repositories, the assumption is you have big data. And what people do, yes, in the early days, people used often only 1 or 2 projects, but nowadays they would go over all of GitHub, all projects in GitHub, and do an analysis. So you have really big data and your analysis becomes very, very refined. Okay, but very good question.
Also, I guess another good thing about that is that if you push to production on Fridays, if you have issues, then it becomes hard to fix. Like, even if you have issues, which sometimes happens, despite like your best intentions, like it becomes harder to fix than if you just release on a weekday, then you have enough time to fix issues as they are, right? Yeah.
But again, a lot of companies do 24/7, right? Production.
Yeah.
A lot of companies don't have any more of a 5-day work week, in terms of, yes, the individual has, but really a lot of organizations, big companies are doing 24/7. They don't shut down anymore on weekends. But very good question. But still, a typical bank, typical, a more mature organization, we will definitely have less staff on the weekends. So yes, that would be another reason why you don't want to release your product on a Friday, because on the weekend you have smaller staff.
But here one more point comes up. When we follow the agile methodology, obviously we have a sprint structure, and then sprint has generally 14 days or 15 days of a span. And at that time, at the end of when we close the sprint, the story deliverables have to be delivered. Then there is no as such rule that we less people work on Monday or Friday. It's like we have certain stories assigned, we have to deliver them by the end of the sprint.
Yes.
At
So
that time,
so it really depends, right, in your context,
Yeah.
right? But but still people are based
yeah,
on
people are not so much productive on Monday. They have Monday blues. That's
Right.
quite obvious.
right.
But yeah.
So now how else could we use a lot of the information which we have in the repositories? You're programming and you might get actually a notification saying, no, it's not only a syntactical error, right? That's what our compiler would tell you. But there could be also a notification now, hey, somebody else make the same, a similar, or introduce a bug in a similar code in the past, and actually provides you with a code with a problem and even with a correct solution, how it was fixed later on. So using that historical data, we can actually help predicting and suggesting correct solutions. So it's very interesting. And again, so given a change can be warned a developer that there's a bug in it, right? By basically looking for similar code across all the repositories, not only in your project, and if somebody else had a bug in it, you can actually report it, right? And so initially we had 50–60% precision, but again, that's 2006. Now we are again 70–80% range by having more data to mine. So we have more historical data, we have more samples, we have more samples to learn from, and finding these patterns has improved. And we have also more powerful computers for the analysis. Number one, project communication mailing lists, like Slack or whatsoever, right? Where people discuss, and you can do actually social network analysis on these discussion threads. And you can see who is talking with whom. Often they also strongly correlate with code change activities. Okay. And you can look, and you can use different measures like in degree, out degree, who is talking to whom, who is contacting whom, and just helping understanding who's actually working together. Now, that one I can't remember. That one was interesting. You can also mine with social media or instant message boards to find out the morale of your team. So you could measure actually if your people are happy or not. So by looking basically for keywords, if they are related, if a messages tend to be optimistic, if they have reference to time, future tense verbs, etc. So these are certain keywords, and you basically perform information retrieval, maybe natural language processing on these text messages to find out really just in what mood, right? Are your employees, are they still happy? So like with Apache 1.3 release, there was a drop in the optimism. And later on with Apache 2.0, there was a increase in sociability. So people were more friendly, communicated, different types of wording was used. Very interesting, right? So that's how companies can also see, are my employees happy? So people have also mined the source code. We looked at API usage patterns, at copy-paste code. Maybe we'll talk about that one later. We mined it for different software categories, classified them, seeing who did what, different types of program rules. And remember, these are just the beginning of MSR. In the last 10, 15 years, there was an abundant number of people trying to find mining for information in these repositories. Okay. How many are useful? How many are not useful? That's a good question, right? Just because you can mine things, it doesn't mean it's necessarily always useful. And I will give you an article to read, and you will see one article talks about fool's gold. It's a little bit like a gold rush, the mining software repositories. Anybody was mining for something, but at the end, there was just so much fool's gold, right? Everybody reports something, but a lot of the things were not actually relevant anymore. They couldn't really find any real reason why, how companies, how organizations, how individuals could actually use it. So that is the downside. But at the same time, mining software repositories can be used to help traceability, non-existing, right? Recovering some of the traceability links which we should have in the first hand. People try to restructure, recover from this big data, from these repositories by mining and looking at patterns. They try to figure out who worked at whom, team structure. You could maybe even relate it maybe to some functionality, to features. Where is my feature implemented? By analyzing, who worked on which code fragment, etc., right? People have mined software or execution traces. I skip it and that's it. So that was fun, right? I keep 10, 15 years of software engineering, software maintenance history I packed in 20 minutes. In general, see it like, I think the best example what people do with mining software repositories is what you see at Amazon. You go shopping at Amazon, you get always recommendations, right? Suggestions. What type of suggestions are you getting? What other people bought? Similar items. So items in a similar category, often bought together, right? And that's all based on what? Data analytics. And mining software repositories, one application would be such type of data analytics, prediction of patterns, okay? Does that make sense? Anybody? Yes, no?
Right.
I still have internet, right? You still hear me, right?
Yes,
you still
yes.
see me.
Yes, Professor.
Not that I talked for the last 20 minutes and nobody could hear and see me. Good. I had my monologue. No, so I will post, I'm not sure, maybe I did already, a short article from IEEE software, which basically summarizes on 3-4 pages some of the also critical aspects of mining software repositories. Okay. Good.
Okay.
So that was fun.
Professor?
Yep.
Like you said, this is, I believe, a very popular research area. Are there like any specific tools that people use to actually mine these repositories?
Yes. any type of machine learning algorithms library, right? That's it. Deep learning, neural networks, you name it, right? Because it's really what you're looking for patterns. Okay, so you extract facts and then you look for patterns. So most important part is you have to have enough data for two things, for learning and then to analyze, right?
Yeah.
So for learning, because your machine algorithms typically have to have some training data. So you have to annotate what is true, what is false. You have to identify, you basically have to identify the patterns, right? You have to help them training the patterns. And then you need enough data to analyze in order to provide some generalizability. But you can actually say, hey, my patterns, my rules, which I identify, which my algorithm identified, they are actually applicable for most systems. If your data set is too small, let's say you only use 1 or 2 projects, or what you can claim would be, my results are only applicable for these type of projects, but you cannot generalize it. So that's why the two major, really the major part is to have sufficient data and sufficient training data. And training data is data which typically has to be labeled manually. So somebody has to annotate what is right, what is wrong, so that the algorithms can learn. Right, so these are the major challenges from the machine learning, from the mining, from the data analysis. You do have so many libraries, right, which actually do your different classification, mining, machine learning implementations are all available in all languages. So for machine learning, from a mining part itself, it's a rather straightforward task. And the work there is just on optimizing performance and maybe scalability, right, of these libraries. But the basic algorithms are there and they are available, readily available for easy reuse by anybody. So it's really just finding the data which you want to analyze, annotate it, and then you run your machine learning over it and you can report some patterns. Okay. But since it's so easy, a lot of people did it, right? And you have a lot of paper published, and a lot of these results which are published are actually not really that useful. I could, for example, say a program which has source code variable names which have more A's than B's in the name are more likely to have a fault, right? I could make a statement. And, yes, if I do my data analysis, I might be able to find some empirical evidence that maybe variable names with an A are more likely to have a bug in it than variable names with a B. But is it really relevant? I don't think so, right?
So you are saying people just using the but they are not really bringing out any useful information, any relevant conclusions.
So really the real findings were, what is really the take-home message? How can actually make it actionable, right? Make it really actionable data that somebody can actually benefit from it, right? Might often not be there. It's like 20 years ago, measurements, metrics were a big thing, right? And you can measure anything, right? You can measure how many spaces you have, you can measure how many lines, and size is okay, right? But you could measure whatever. But most of the measurements actually at the end, they found out basically didn't really contribute anything. I could measure the air pressure and the bugs, right? Does it make a change? Can anybody really do anything? Maybe, maybe not, right? Okay.
Yeah.
But have a look at the one paper. If I haven't posted it, I will post it. It has also one critical article, right? Which basically summarizes it.
Okay.
Easy to read, fun to read. That's my objective. I want to make it both so that you can, since we don't have a textbook, the papers are typically pretty easy. What is debt in a financial sense? Do you have any financial debt? And then what are some of the reasons? Is debt always ever a bad thing? Let's talk. So you don't have to say if you have a debt, right? But you can say, I know people who have financial debt. Everybody knows or has or knows somebody who has some financial debt. What are typical ones? Financial debts? Credit cards, right? A mortgage on a house, a car loan. You buy a new computer, you take out a loan. Agreed? Installments. It's basically what? Financial debt, right? Agreed? Anybody?
Yes, Professor. So
yes. Yeah. So, what are some of the reasons why we have debt? Why would you take out a loan? I guess nobody of you has ever taken out a loan or has any type of debt or doesn't know anybody who has a debt. Why would somebody, yeah?
So we usually take a debt to basically deliver us, whatever we require. So for a house, we take a loan so that we can deliver ourselves the house easily, quick.
Yeah.
And that is why when we go for technical debts.
Oh, yeah, no technical debt, just financial, right?
Okay.
So sometimes, you want to have a house, but you cannot afford it. You don't have the cash to buy it, right? So you buy yourself some time until you have actually enough cash. But so in the meanwhile, you take out a loan, but in the form of a mortgage, in the form of a car loan, so that you can actually get the car, use it, but you own, right? So is that always ever a bad thing? What do you think?
Depends if you take it
Depends
for
is very
granted.
good. Depends is very good. Now, on what?
Depends upon whether the
Amount.
person is able to follow. Obviously, debt is come with the condition. It's not always if you have taken even a loan, it's always with a condition. So if you are able to fulfill that, you're good to go. But you should not be used to or take it for granted.
Mm-hmm. Somebody else.
It's not a bad thing unless and until you follow the process.
Yeah.
It can also depend on what's the loan for? Is it for an asset or is it for a liability?
Mm-hmm.
So assets gonna grow, liability is gonna depreciate. So the value of loan.
Very good. So depends for what you take out the loan, depends if you actually pay it off, right? If you have actually the means to pay it off. Because like a credit card, if you do the minimum payment, you might pay it off at one point, but given the interest rate, it will take 20 years, right? And so it might not be just the minimum, right? So people have to figure out what they can really afford. So now what about technical debt? Some similar familiar experience. As the process goes on with software product, costs are rising and customer responsive is failing or falling, right? That's what we talked about in the course. Once product gets older, it becomes more and more expensive to keep it running. Using an obscure, incomplete error message could because it's too hard to figure out how to do it right, which is, for example, one thing which we might find. People are under time pressure, right? And they just put a stupid error message. Something went wrong, but without specifying what, or an error code, or explaining. So we have an error message, but we know it's actually useless. We might know it at the time when we are debugging, but later on, if actually the error happens, it doesn't really tell you much. Often it's related to rushing for a shippable product to meet your deadlines, right? So people are cutting corners. And as a result, really, after a couple of years, the system might actually getting paralyzed because you have cut too many corners, and mostly, like missing documentation, missing comments, not clean source code, etc. So what are some of the consequences of technical debt? It's a slapdash architecture. We just patched together at one point. There's poor design, there's hasty coding. It's not just rapid, it's really not clean coding. There's no focus anymore on quality. And really the danger, like in financial debt, is really, the danger occurs when the debt is not repaid quickly. Meaning, yes, we are rushing for a deadline to meet our product deadline. And we know there are things which we should clean up and fix. And the problem is, if we don't fix them, we start accumulating. And it's really like financial debt, right? Once you have more and more debt, at one point you might not be able to pay it off anymore. Okay. So every minute spent on not quite right code results in interest on that debt, because you have it and you collect more, and it causes problems. So technical debt is really the cost associated with a lesser software system that became difficult to maintain and improve. Okay, so, and that will basically impact our ability to add features and new things. And so it's delayed technical work due to shortcuts which we have taken. So we didn't comment, we didn't indent our source code properly because we had other things, our deadlines. Now the interesting part. So if we look at a curve, product over years and the cost of a change, the optimum cost of change, we know it will go up no matter what, right? Because our software, it's getting more and more difficult to maintain. So we have seen. But now the problem is with each product release or whatsoever, we might also introduce new technical debt. And if we don't pay it off, our cost of change will increase much, much faster. So it becomes our actual cost of change. And what it leads to is that our customer responsiveness at the same time, how fast we can react to feature requests or bug fixes, goes actually down. So what we hit is at one point the point where our responsiveness is low, our cost is high, and we have a real problem. Okay. So technical debt can be in two axes: reckless, prudent, and deliberate, inadvertent. Reckless, deliberable, we do not have time for design. We're just really stupid. Design has to be there, right? It should be, it will backfire. Also, reckless and inadvertent, what is layering? So here we add now something. We have not only, but we're saying we don't use design. We actually don't know what design is. We don't know really how to do it. Here we do it deliberate. We must ship now and deal with the consequences. We know we have problems, but we say, okay, we will fix it later. And also bad is now we know how we should have done it. Also not good. We agree? But these are all consequences really of how technical debt might impact. I don't show the video. You can watch it later. So symptoms of technical debt is we have poor customer responsiveness, longer delivery times, late deliveries, lots of defects, rising develop or maintenance costs, and also our team really becomes frustrated. It becomes a constant fighting between getting things done on time and doing it properly. So what we need is actually some technical debt metrics. And these are questions, how can I effectively measure how much technical debt I already have? And once we can measure it, we can actually also see which part of our system have actually the most technical debt. And then we could define, once we have these metrics, we can actually define how much is too much. We can put a threshold. If we go about a certain measurement level, we actually have to pay off our debt. And then we should also figure out how much will it cost me to get out from my high interest debt, from the places where we have a lot of technical debt. And so there are some tools which can be used to analyze your source code. Okay. And I will post an assignment 3, which is going to, where you're going to use a tool to measure the technical debt of any open source project. Now, if we talk about technical debt, what are we looking for? Duplicate code. Rule compliances could be, for example, every class, every constructor, every class should have a user-defined constructor. Comments at the interface level, comments in general. We can look at the package dependencies. Do we have too much coupling, maybe between method class complexity? So these are some measurement statistics. Do we have classes which actually should be broken down so that we become more manageable? Automated test coverage. Do we have enough test coverage? Tests available? Okay, so that's just a few of these technical debts what we could. But that also could be your priority. You know, you could say, okay, duplicate code is my highest priority. It's my really, that's the most important debt, which has the highest interest. We should be first fixed, like programming standards, violation to programming standards in my organization. They should be fixed to make it more consistent, right? Our source code. So who is suffering from the technical debt? Customers. Now, they are actually the biggest victims. At the same time, customers also give initially more priority really to features over long-term maintainability, right? Because we offloaded really what? To the programmers. They don't care, right? They want really features, but in the long term, they are actually the ones who are suffering from it. Help desk, because they have to, you know, deal with the problems. They are the first point of contact for customers. Operations. I will talk about DevOps in 1 or 2 lectures. How we address that problem. The engineers, developers, implement the code, and maintainers repair. perceived as developers and strongest yet maintainers do the hardest job, right? Really, so the problem is between maintainers and developers, right? We have the image problem. Marketing, for them, it's really usually must deal with the displeasure of the customer in the case of technical debt. Why? Because the release times might get longer, right? It becomes more difficult to satisfy your customers. And management. Good. Making a repayment plan. Very interesting. Engage, motivate. Motivation and a plan lead exponential value to the customer. Right? So we know if we actually have clean code, which is easier to maintain, we will have happier customer because we can provide easier fixes, quicker with new features. But it's important that we get the manager, you have to get the management involved. You have to explain to them what is technical debt and why they should care. Because you have to explain how it's impacting the cost, the delivery, and the morale of your team and customers, right? Because management, they are the one who have to provide the budget. Because repaying technical debt requires investment by management to actually put people aside, to give people time to clean up, to pay off the technical debt. And then you have to make a realistic plan and also a model on how to proceed with paying off. So what strategies for paying down technical debt? Poor coding and testing practices, from a lack of time and or knowledge to do it right. So each team member should invest in their own knowledge and education on how to write clean codes related to a business domain and how to do their job optimally. Basically, give people also some time. It's 8 o'clock. Good. Thank you. Thank you. I almost overlooked it in the chat. So you were living a risky here because I don't always check my chat messages. Good. Let's call it an evening. I will give you another assignment on tech. So it's an assignment where you use a tool to analyze a software project. You can use the same UMLED or any other source code project which you want and analyze it for technical debt. So all what you have to do is basically install that open source project, provide as an input the source code of an existing project, and then basically just report on the technical debt it reports, if you can. Again, I will put a time limit, and it's more about seeing what tools can report, and then we will talk about some of these results next week. Okay. Also, I'm going to give you before the midterm another slicing problem. Okay, to practice. And it might be as an assignment or just as an exercise with a sample solution. I will see. Any questions, any comments?
Yeah, Professor, I just have one question regarding the assignment of technical debt. So would we be just writing down the technical debt, just in a file as a theory, or
Nope. But you will use one of the state-of-the-art tools, which is actually used by many companies, and that tool will create a report.
Oh, okay.
So there's nothing what you have to calculate, right? It will tell you how much your debt is, and you can take any project, right? You can download any compatible. It tells you which types of program, which type of programming languages it supports, and then just try it. So it's really just exploring and trying to get a feeling of what's actually out there, right? And how what it might look like. Good.
And it would be an individual assignment, right?
Yeah, it's fun. So, and I would give it 4 or 5 hours maximum, right? But if you have problems installing it, it's okay. Give it a try, and then if after 5 hours, if you can't figure it out, call it a day. But normally, most people can install it and run it. Okay.
Sure, so thank you.
Sorry to interrupt you, doctor. I'm sorry I'm asking you to repeat that again, but regarding the midterm and that slicing problem, what you just said, can you please repeat it again?
Oh, I will give you either one more assignment or some exercises with sample solutions. Okay, to practice. And I will anyways give at least 1 or 2, I give at least 2 weeks prior to the midterm. I will announce it and I will provide a coverage.
Okay.
And I will give you also some questions from old midterms that you see what are my question style. Okay?
Okay, great.
So it should be straightforward.
Yeah, okay, thanks.
Good. So see you next week in person, probably.
Excuse me, Professor.
Yes.
Thank you so much.
About midterm exam, should we, I don't know, memorize all this material? I mean,
no. No. Understand. Create yourself a domain model, right? How the concepts are related. What is the general goal of mining software repositories? I don't care the individual, right? Okay, what is software traceability? You will see, I will give you 1 or 2 or 3 sample questions from old exams, okay?
Okay, thank you so much.
And you will understand, it's basically, I give you a scenario and it's mostly looking at the context and it's more understanding. Yes, you have to read through the lecture notes, but really what my suggestion will be, try to abstract, try to create yourself a domain model of how things are related, okay?
Okay, thank you.
Good.
Hi, doctor.
Somebody was asking for my email. It's on each, create a mental model, yes. A high-level mental model. We don't have to go all the level down. Top down. Good. I just always good. Let me stop the share and let me stop the video. Or any other questions? Anyways, see you next week in class. Like I mentioned, if I will try on Thursday with my undergraduate, if I can record it, and have a live Zoom at the same time from the classroom. But since the infrastructure is basic, I have to provide my own laptop for the Zoom, and so I'm not sure about the sound quality. I might try my headset. We'll see what I can manage. Okay. But I'll let you know by Saturday, Sunday, how it goes. Good. Any other questions?
Yeah, doctor. So I do have some questions regarding the sample answers that you have provided for assignment 2.
Yeah.
So as far as I know, the slices must be executable, right?
Yes.
So I see in some sample answers, there is no line 3. Like if you see the text. So one question is, are the sample answers final answers? Like should we consider?
No. I have a couple of problems which I'm going to fix.
Okay, so the sample answers are not the final answers yet, right?
No.
Because I found like 3 problems in it, and then I'm not sure if I'm
correct, but they were mentioned, right? So I will fix them.
Okay, sure. So they're not the final answers, right?
No, because I was rushing before the lecture.
Okay, perfect. Thank you. That was my question.
Yep.
Yeah. Thank you so much, Prof.
Yep. Anybody else?
Professor, when will the midterm be held on? I mean, just an approximate date.
It's around the spring break, right? End of February, beginning of. So we still have time, right? I will ask you, I will double check maybe next week with you to see what works better for most of you in terms of not having too many exams in 1 week. Okay?
Oh yeah, I mean, that would be great.
Yeah, I'm flexible. Good, perfect. Any other questions? Otherwise, have a great evening, have a great weekend. Enjoy the snow tomorrow on Thursday. Enjoy the snow. Enjoy the 2 or 3 days of warm weather. Relatively speaking, see you next week, Tuesday. Bye.
Thank you so much, Professor. Have a good day.
See you.